Hello, good morning students, and welcome back once again to class 9 gravitation chapter, and we'll continue with the exercise and today's numericals. A stone is released from a tower of height 19.6 meters. Calculate its velocity just before touching the ground. So the stone is released from a height, okay, and it is falling down towards the ground. Obviously when it touches the ground, okay, at that point after touching the ground, its velocity will become 0. But initially when it just touches the ground, it will have the maximum velocity possible. Okay, and we need to find that velocity. What will be that velocity? And for that we have a simple formula: v square minus u square equals 2gh. Okay, that is finding the velocity. We can use v is equal to u plus at as well, but we don't have the time. Now because this stone is free falling, we'll take the value of g as 9.8 meters per second square. Like I said, when it is not given, you will always use the acceleration as 9.8 meters per second square. If it is given, like in the next numerical, it will be given taking the value of g as 10 meters per second square. But in this question, it is not given. So you'll use the value of g as 9.8. You need to find the final velocity, because when the object or the stone is released, at that time it will be having initial velocity 0. So when the initial velocity is 0, you need to find final velocity. V square minus 0 square equals 2. G is 9.8 into h, that is also given 19.6. So 19.6. So V square minus 0 square is the number itself, and 2 into 9.8 will give you 19.6. 2 8 16, 1 carry forward, 2 9 18, 19 and 1 decimal point, and you have 19.6 as it is. That is the height of the tower. Now obviously you want velocity, not v square. Okay, so when you want just velocity, you take square root on this side, so you take square root on the other side as well. Okay, and when you do that, one of the 19.6 will be removed. So over here v square becomes v, and 19.6 becomes just 19.6, and therefore its velocity will be 19.6 meters per second. Quite easy actually. I'll give you a moment to see what the numerical is. Let's revise it. A stone is released from a certain height, and therefore you will use the equations of motion. You have v is equal to u plus at, s equals ut plus half at square, and third one is v square minus u square equals 2gh. Obviously the second one is not required, because in the second equation s is equal to ut plus half at square. In this equation you don't have the final velocity, and that is why you use either the first equation or the third equation. But in the first equation you don't have the time, and therefore the only remaining equation is the third equation. In this you have initial velocity, you have acceleration, you have height. So you just need to put the values of those and you will get the value of final velocity. And because the stone is released, and therefore its initial velocity is taken as 0, g we know that is acceleration due to gravity 9.8, and the height is given 19.6, and 2 into 9.8 will give you 19.6, and 19.6 is the height as it is, so you write 19.6 into 19.6. Now obviously you don't want the value of v square, you just want the value of final velocity v. So we'll take the square root of v square on the left hand side, and therefore you take the square root on the right hand side of the equal to sign as well, and therefore the final velocity v, that is 19.6 and 19.6, one of them, because we are doing square root, so it is just 19.6. I hope it is clear to you students. Quite easy. Okay, so the next one, a stone is thrown vertically upwards. It is similar to the one that we did in the classroom. Okay, a stone is thrown vertically upwards with a velocity of 40 meters per second. Taking g as 10 meters per second square, find the maximum height. What is the net displacement and total distance of the stone? Okay, so first we'll start with the maximum height. So it is given that it is thrown upwards with the velocity of 40 meters per second. So you have been given initial velocity 40 meters per second. Obviously when an object is thrown upwards, it is going to go up and it is going to come down, and therefore over here initial velocity is 40, but when it reaches the maximum height it becomes 0. So we have initial velocity, we have final velocity, we have the value of g, that is 10, but obviously if it is thrown upwards, we take the value of g as minus 10 meters per second square. So we take the value of g as minus 10. Okay, and we find the maximum height. Once again, we have to use the same formula, this one, v square minus u square equals 2gh, because you need to find the height. Quite simple. Okay, so you substitute the values, v square minus u square equals 2gh, v square is 0 minus u square is 40, 2, g is taken as minus 10, and h you need to find. 0 minus any number is the number with a negative sign, so I will write minus. 4 is 16, 0, so I will write 2 zeros over here. 2 into 10 is minus 20 into h. Now I want the value of h, so it will become cross multiplication, so minus 1600 upon minus 20 equals h, or I can write h is equal to minus 1600 upon minus 20. This negative sign will get cancelled. 0 and 0 cut. 2, 8 is 16 and 1, 0. So the answer is 80 meters. So it will achieve the height of 80 meters. Okay. I will repeat once again. You have 1600 upon 20. So 0 and 0 is cancelled. 2, 8 is 16 and 1, 0 as it is. So you have 80 as the answer, and that has been written over here. So you have the height. Achieved maximum height is 80 meters. Now obviously the next part of the question, first I will write the height 80 meters, that is our answer. Finding the net displacement, obviously when the stone is thrown upwards, it is going to come down, so its initial and final point are the same, therefore it has travelled no distance, it has travelled no displacement, its initial and final points are the same. After travelling a certain distance, it is coming back to the same point, and therefore its initial and final points being the same, therefore its net displacement is 0. This is what we studied in the very first chapter. Okay, so displacement is 0 meters because its initial and final points are the same. If you remember, we talked about displacement. If a person or an object travels a certain amount of distance but comes back to the same point, therefore its displacement is 0. But if it travels to a certain point and stays there, then we can find the displacement, that is the shortest line joining the two points, initial and final point. Okay, so we know the displacement is 0, but what is the total distance? So total distance traveled is from point A to B, that is 80 meters, and then when it is coming back, it is traveling once again 80 meters. So the total distance traveled by the stone is 160 meters. It is going up 80 meters and coming down 80 meters. So 80 plus 80 is the total distance traveled by the stone. I hope it is clear to you, students. Moving on to the next numerical. Okay, students. So the new question requires a little bit of understanding and for you to pay attention a little bit more because it is a complicated one. A stone is allowed to fall from a top of a tower 100 meter high, and at the same time another stone is thrown upwards with the velocity of 25 meters per second. So first of all, we take a height of 100 meters, total 100 meters, and from there a stone is dropped. Okay. And the next part is at the same time another stone is thrown upwards with an initial velocity of 25 meters per second. This one is having initial velocity u as 0 because it is being dropped. Okay. Calculate when and where will the two stones meet. So first of all, when, that means we need to find the time when these two stones will meet each other, and the second is where will they meet. So let's say that this stone travels a distance of s meters over here, s meters because we don't know, and this stone, what is the remaining distance? If this is s meters, not 5, if this is s meters, then the remaining is 100 minus s meters. So if this stone travels s meters, then the remaining is 100 minus s meters distance, and at this point these two stones will meet. So if we find this s meters of distance, we can find the distance from where these two stones meet. Okay, from the top, And if you want to find at what distance they will meet from the bottom, you can find that as well. If you find the S, you will find that from bottom, if this stone travels this much distance, at that point they will meet, or from the bottom they will meet this much distance, and from top at this much distance they will meet with each other. So first of all, we require the time as well, and we require the distance. So simple, the distance formula S is equal to ut plus half gt square. Okay, and S is what you need to find. So first we'll use for this stone which is being dropped. Okay, so for the stone dropped, we'll write over here, because we'll require two equations for this. And S is equal to, initial velocity is 0 plus half, and what is G? G is given as 10 into t square. So I'll write 2 5s 10, because they are in multiplication, I can cut them, and therefore I get S is equal to 0 plus any number is number itself, and over here the only thing remaining is S is equal to 5t square. So I have S is equal to 5t square. I'll give this equation 1. Similarly, for the next one, I am writing S dash equals ut plus half gt square for stone thrown upwards. The formula will be same obviously, but the only difference, this is S dash. And what is S dash? Because if it is thrown upwards, we require 100 minus S distance. So I am writing 100 minus S, okay, is given as ut plus half gt square. Once again, now over here u is 25. Remember that, students, initial velocity is 25, not 0, because it is being thrown at a certain distance. So I will write 25 meters, time you need to find, plus half. Now because this is thrown upwards, we'll take g as minus 10 and t square over here. So I'm writing 2 5. So the next thing becomes 25t minus 5t square, because minus plus minus minus over here, minus 5t square, and 25t as it is, and 100. And what is the value of S we have? That is 5t square. So we substitute this value of S over here in this equation. So 100 minus S, I am writing minus 5t square. Okay, now you can see that over here minus 5t square and minus 5t square, they both are same on the equal to sign. So if I take this minus 5t square over this side, it becomes plus 5t square, and minus 2 plus 2 becomes 0. Similarly, minus 5t square plus 5t square becomes 0. Okay, so I can cancel these 2 points over here, and therefore what I get remaining is 100 equals 25t. Okay, what I have is 100 equals 25t, and therefore I can write 100 upon 25 equals t, or I can write t equals 100 upon 25, and 25 fours 100. So the time that is t is equal to 4 seconds. So they will meet after 4 seconds. So when will they meet? So they will meet after 4 seconds. So we have found the time. Now the distance. So to find the distance, we simply use this formula, that is S is equal to 5t square. So S is equal to 5 into t square, that is 4 square. And what you do over here, S is equal to 4 fours is 16, and 16 into 5, 5 6 30, 5 1 5 6 7 8, and you get 80. So the answer is 80 meters, and therefore the distance S is 80 meters. So when the stone is thrown from the top and another stone from the bottom, they will meet at 80 meters from the top, or I can write they will meet at 100 minus 80 is equal to 20 meters, that is 100 minus S. So I'll get 20 meters. So they will meet 20 meters from the bottom, or I can say they will meet at 80 meters from the top. I hope it is clear to you, students. Very simple. You take the values, that is initial velocity over here 0, initial velocity from the bottom for another stone 25, you take the distance S from the bottom, remaining is 100 minus S. S is equal to ut plus half gt square. Substitute the values. You can do the same for the other one, but this time you have to write the distance as 100 minus S. And once you write all the values, finally substitute the value of S, that is 5t square, in the other equation, and minus 5t square minus 5t square from the equal to sign on both the side will get cancelled. cancelled, so remaining is 100 equals 25t. So the time that you will find is 4 seconds. So they'll meet after 4 seconds, and substitute this time in our first equation, that is s is equal to 5t square, and what you get is 80 meters from the top, and from the bottom 100 minus 80 is 20 remaining. So from the bottom 20 meters and from the top 80 meters. I hope it is clear to you, students. I'll see you in the next video. Till then, have a nice day.